one method. Okay, here that what we are going to do, we are going to use a flip flops. Okay, here I am going to use the D flip flop. Okay, to design a logic diagram to generate this sequence. Okay, here in order to design the logic diagram, here we have to know how many number of flip flops that we have to use to design to generate this particular sequence. So that here we are using a simple condition, that is nothing but here L is capital L is nothing but a length of a sequence. Okay, here we have 1, 2, 3, 4, 5 bits are there in our sequence. Okay, so that here capital L is nothing but 5. Okay, is less than or equal to 2 to the power of n minus 1. Here small n is going to representing the number of flip flops. Okay, so if you see here L is equal to 5, so that okay 5 less than or equal, in which cases this condition is going to get true. For example, if I take here n is equal to 1 means here we are going to get 2 power of 1 minus 1 is nothing but we are going to get 1, so that the condition is false. So what I am going to do, here I am going to take n is equal to 3, 2 power of 3 is nothing but 8, 8 minus 1 is nothing but 7, so that in this case the condition is true. Is it clear? So that here we have to use the minimum number of flip flops are here 3. Is it clear? So that in order to design this particular sequence or logic diagram, here we have to use how many flip flops? Here we have to use 3 flip flops. Okay, so that here small n is nothing but 3. Is it clear? So by using 3 flip flops, next what we are going to do, we are going to design the logic diagram. So what I am going to do, here I am going to take A, B, C. Okay, 1, 2, 3 flip flops. Okay, and I am going to write the sequence. See here, here we have to write the given sequence in vertical fashion. Okay, 1, 0, 1, 1, 0. Is it clear? This is related to the first flip flop. Okay, next what I am going to do, I am going to shift this one to here. I am giving the first flip flop output to the second flip flop, so that here we are going to get 0. Here I am putting this 0 here, and next 1, 0, 1, 1. Is it clear? This time rotating like this. Here it is equal to 1. Next this one here. 0, 1, 0, 1. Is it clear? After getting this sequence, here we have to see is there any repetitions are there in the horizontal rows. Okay, if you see here it is equal to 101. Okay, and here we have to see is there any 101 sequence is there in the remaining 4 rows. Is it clear? Here we have 010, so it is not equal to 101. Next one is 101, so that this sequence and this one, these two are same. Is it clear? Okay, next we don't have, and the next also it is not equal. Here we have 2 sequences are repeated here, so that in order to avoid this one, that what I am going to do, here I am going to taking, or here I am going to considering one more flip flop, that is nothing but a, the name of that one is D. Okay, so again that what I am going to do, again I am going to repeating the same process. Okay, 1, 1, so clear. Next 0, 1, 0. Again in this, here we have to see is there any sequences coming repeatedly or not. Okay, here the very first one is 1011. Here we are not going to find that one in any row. Is it clear? So that what we have to do, we have to stop the taking of number of flip flops. Next, here we are going to take the last one, that is nothing but a feedback. We are going to represent that one is F. Okay, again I am going to shift this one time, 0, 1, 1, 0, 1. Okay, here I am going to finding the equation for F. Okay, here I am going to derive the equation for F. by using A, B, C, D. Is it clear? Okay. Here we are going to deriving this one by using a 4-bit K map. Okay. So that here I am going to considering a 4-bit variable K map. Okay. Already we know 4-bit variable K map. Okay. This is A, B, C, D. Okay. The very first one is, first row is nothing but 0, 0, 0, 1, 1, 1, 1, 0. Here also here C bar D bar, that is nothing but 0, 0, C bar D, that is nothing but 0, 1, 1, 1, 1, 0. See, here when the F value is equal to 0, that means for what combinations of A, B, C, D, the F value is equal to 0 and 1, we have to write in the K map to simplify the K map. Here F is equal to 0 when AB is equal to 1, 0 and CD is equal to 1, 1. AB 1, 0 is nothing but here we can find 1, 0 and CD is equal to 1, 1 means here. So that the intersecting point of these two are here is equal to this one. So that in this cell here we have to write 0. Similarly, next one is 0, 1, 0, 1. This is equal to 0, 1 and it is equal to 0, 1. These two are going to meet here so that it is equal to here 1. Similarly, 1, 0, 1, 0. Here it is equal to 1, 0 and here it is equal to 1, 0. So that here we have to write F value here is equal to 1. Next one is 1, 1, 0, 1. For this F value here is equal to 0. That means AB is equal to 1, 1 and CD is equal to 0. Okay. This is equal to 1, 1 and CD is equal to 0, 1. 0, 1 here is nothing but this one. It is equal to. So that here it is equal to 1. Yeah, sorry. Here it is equal to 0. It's clear. Next one is 0, 1, 1, 0. It is equal to 0, 1 and it is equal to 1, 0. So that here we are going to get. Okay. In the remaining cells, that what we have to consider these cells are here is nothing but a dot K cells. Okay. The rest of the cells that what we have to do, we have to consider as a 0. Next, in order to minimize, okay, in order to solve the expression for F, that what we have to do, here we have to see the K variable, K map rules and regulations. Okay. First, what we have to do, we have to see for the quads. Okay. If quad is not possible means next we have to go to pair. Okay. See here, can we make these 4 cells? Okay. And these 4 cells one octet. Shall I make like this? See here, these 4 cells and these 4 cells are going to form a quad, octet. Okay, quad plus quad is nothing but octet. So that here the variable here is 0, 0, 1, 0. Okay, here the variable here is equal to C value. Okay, here C is equal to C bar and here C is equal to C. C plus C bar is nothing but 1. Here it is equal to D bar and here it is equal to D bar. So that here this A bar, B bar, A bar, B, A, B, A, B bar. Total literals, that means the literal A and B are going to get eliminated here. Here we are going to get only D bar. Is it clear? Okay. And the next what I am going to do, next we have to think about this one, this minterm. Okay. See here, what I am going to do, here I am going to make these 8 cells is equal to 1 quad, 1 octet. Okay. This is 1 quad and this is second quad. So that for this row means your total C and D element is going to get eliminated. And here 0, 0, 0, 1. So that in this common here is 0. That is nothing but A bar. This is A bar, B bar, A bar, B. If you take common A bar means B bar plus B is nothing but 1. So that 1 into A bar is nothing but we are going to get A bar. Is it clear? So that we are going to get the final expression for F is equal to A bar plus D bar. Okay. So we got the expression for F. Next what we have to do? We have to design the logic diagram. In order to design the logic diagram to generate a sequence 1, 0, 1, 1, 0, here we need 1, 2, 3, 4 flip-flops. So that what I am going to do, here I am going to take 4 D flip-flops to design 10110 sequence. This is the third flip flop, D flip flop, and this is the fourth D flip flop. Okay, these flip flops are having, this is a DA, and it is going to generate two outputs, QA and QA bar. Similarly, QB and QB bar, QC, QC bar, QD, QD bar. Okay. Here we are going to use sequential circuits. Okay. And here we are going to considering a negative edge clock signal. Here we have to use a clock signal. Okay. This is nothing but a QA bar, QB bar, QC bar, and QD bar. Here we have total 4 flip flops are there. This is nothing but a DB. Okay. Second flip flop. We are using here D flip flops. Okay. D flip flop is having a clock signal, and the input is nothing but DA, first flip flop, and the output is two outputs. One is QA and QA bar. Okay. Here we have to give the very first flip flop output to the input to the second flip flop. Similarly, second flip flop output to the output is input to the third flip flop. Similarly, third one is input to the fourth flip flop. And here we are going to get QD and QD bar. Here we got an expression for F is nothing but A bar plus D bar. Here A bar is nothing but QA bar. So that here we have to, from here we have to take A bar, and here D bar is nothing but QD bar. So that here we have to take this one. And here the expression for F is equal to A bar plus D bar. So that here we have to give these two to OR gate. This is nothing but here F. F is equal A bar plus D bar. This is nothing but a D bar, and this is nothing but a bar. We are going to get here expression for F is equal A bar plus D bar. This is nothing but a clock signal. So that this clock signal, this logic circuit is going to generating a sequence is nothing but here 10110. This is about the sequence generator. Okay, thank you. Today we are going to see a sequence generator. Okay, in digital electronics. Okay. Here we are going to generate a sequence 110010 sequence by using a simple logic diagram. Okay. Here that what we are going to do in the sequence generator, we are going to design a logic circuit. Okay. Based on that logic circuit, that what we are going to do, it is going to generate a continuous sequence like this. That means 110010. Okay. Before going to design the logic circuit, here we have to know how many number of flip-flops that we have to use to generate a sequence like this. Further, here we have a condition that is nothing but L less than or equal to 2 to the power of n minus 1. Here L is nothing but number of bits in the sequence. Okay. Here how many bits we have? 1, 2, 3, 4, 5, 6. Here capital L is nothing but 6. Here the capital L is equal to 6. Okay. And if you take here n is equal to 3 means, okay, 2 power of 3 is nothing but 8. 8 minus 1 is nothing but 7. So that here n is equal to 3 value is going to satisfy this condition. If you take n is equal to 2 means, here 2 power of 2 is nothing but a 4. 4 minus 1 is equal to 3. It is not going to satisfy this condition. Why? Because here 6 is greater than 3. So that for the condition n is equal to 3, it is going to satisfy the condition. Is it clear? So here we required total number of flip-flops to design a logic diagram to generate a sequence like this, here we need 3 flip-flops. So that here that what I am going to do, here I am going to take A, B, C. 3 flip-flops I am going to take, and here what about the sequence that we want to generate? We have to take a sequence here in vertical fashion. That means 1, 1, 0, 0, 1, 0. Next, here that what we are going to do, here we are going to, in the logic circuit, in the logic diagram, that what we are going to do, we are going to give the first flip-flop output is input to the second flip-flop. So here that what I am going to do, here I am going to take this 0 here, okay. Next I am going to take this sequence 1, next 1, 0, 0, 1. Okay. Next one is, here I am going to take this one here, that means 1. I am going to drag down this one, 0, 1, 1. This is equal to 0 and 0. Here we got total 1, 2, 3, 4, 5, 6 rows are there. Here we have to compare each and every row. For example, if any row is repeating in the if any row sequence is repeating in the remaining rows, means what we have to do? We have to add one more flip-flop. For example, if you see here 101 is 101 is repeating in any case. Here it is 101. Here we have 110. Here 011. Here 001. Here 100. So it is not repeating. Similarly, 110. We have any 110 in? No. Next 011. We don't have 011. Next one is 001. Don't have. Next one is 100. Or else you can do one thing. The value of this one here is equal to how much? 1, 2, 4. 4 plus 1, 5. Here it is equal to 6. Here it is equal to 3. Here it is equal to 1. Here it is equal to 4. Here it is equal to 2. So that here no number is repeated. So that what we have to do? We have to take a final feedback, that is nothing but F. Okay. Here that's what we have to. We have to take this one here. That means 0. Next one is 1, 0, 1, 1, 0. Okay. After getting this table, sequence generator table, next here we have to find out the expression for F. Okay. We are going to derive the expression for F, okay, by using K-map. Here we have 3 variables are there, so that here we are going to take a 3 variable K-map. This is A and this is B, C. Okay, this is nothing but A bar, A, that is nothing but 0, 1. Next one is 0, 0, 0, 1, 1, 1, 1, 0. B bar, C bar, B bar, C, B, C, B, C bar. Okay. Here we have to see A is equal to 1 and B, C is equal to 0, 1. A is equal to 1 and B, C is equal to 0, 1. 1, 0, 1 here. The intersect point here. Here the value of F is equal to 0. Next one is 1, 1, 0. It is equal to 1. Next 1, 0 here. The F value here is equal to 1. Next one 0, 1, 1. That means here it is equal to 0 and here it is equal to 1. The next one is no. Here it is equal to 0. F value here is equal to 0. Here next one is 0. A is equal to 0 and BC is equal to 0, 1. A is equal to 0 and BC is equal to 0, 1. For this, F value here is equal to 1. Next one is for A is equal to 1 and BC is equal to 0, 0. We are going to get 1. That means here it is equal to 1. The next one is A is equal to 0 and BC is equal to 1, 0. A is equal to 0 and BC is equal to 1, 0. Here we have 0. Here we have how many ones? 1, 2, 3. So that here also we got 3 ones and here 1, 2, 3, 3 zeros here we got. In the remaining cells, that part we have to do, we have to take here, don't take. It's clear. Okay. Here In order to simplify the expression for f here is equal, okay, here we have to see how many pairs or how many quads that we can do maximum. Okay, maximum that what we have to do, we have to try to make quad. Okay, if quad is not possible means then we have to go for pair. Okay, here we can make these two cells is equal to one pair, or by using these two cells we can make one pair. Okay, and we can make these two cells is equal to one pair. Okay, better by using these two cells we can make one pair, and this is one pair. So that here in, from the rules of the K map, here we have to see, we have to cover minimum number of don't get conditions. So that what I am doing here. Here I am using this minterm and this minterm, and I am going to make one pair, and by using these two I am going to make the another pair. So that for this, here we are going to get the expression here is, it is there in the which row? A bar. So that A bar, and it is there in the two columns 0 0 0 1. Here the fixed one is 0, that is nothing but B. So that here we are going to get B bar. Okay. Here it is C bar, and here it is the C. C plus C bar is equal to 1. So that B bar into C plus C bar is equal to 1. So that we are going to get B bar. Similarly, it is there in the which row? A. So that here we are going to get A, and it is there in the two columns, that is nothing but 0 0 1 0. Here the 0 is fixed, that is nothing but C bar is fixed and B is variable. That means one time B is equal to 0, and here B bar. B bar plus B is equal to 1. So that here we are going to get, it is A C bar. So that we are going to get the final expression for f is equal A bar B bar plus A C bar. Here by using this expression we are going to design a logic circuit to generate a sequence like 1 1 0 0 1 0. So that how many flip flops that we have to use here? Here we have to use 3 flip flops. So that here we are going to take 3 D flip flops. Okay, this is one, this is the second flip flop, and this is the third flip flop. Okay, this is BA. It is going to generate two outputs, QA bar. Similarly, QB bar, QC bar. Okay, here we are going to use a negative edge clock signal. We have to connect all these 3 flip flops to a clock signal. It is nothing but a clock. Okay, and here we have to give the QA output to, that means the first flip flop output to the second flip flop. Similarly, second flip flop output to the third flip flop. And here we are getting the expression for f is equal A bar B bar. Here I am going to give these two to one AND gate, so that it is going to generating here A bar B bar, and the second one is A C bar. Okay, and here these two terms are here connected to one OR gate, so that it is going to generating the final expression f is equal A bar B bar plus AC bar. Thank you.